A circle is inscribed in a right trapezoid ABCD with bases measuring 14 and 35. Let's find the exact radius r. First, look at the geometry. Notice the right angles at vertices A and D. Because the circle is tightly trapped between the bases, the trapezoid's height AD is exactly equal to the circle's diameter, 2r. Now, recall the tangent segments theorem. Tangents drawn from an external point to a circle are equal in length. From vertex B, these two red tangents are equal. Since the top base is 14, each red segment measures exactly 14 minus r. Similarly, from vertex C, the two teal tangents are equal. With a bottom base of 35, each measures 35 minus r. Combining them, the entire slanted side BC is the sum of these two colored pieces, 49 minus 2r. To use algebra, we drop an altitude down to point M, forming a rectangle on the left. So the height BM is 2r, and the remaining base CM is 35 minus 14, which leaves 21. Now, we invoke the Pythagorean theorem on our highlighted right triangle. Expanding the left side, we get this quadratic expression. Look at this. The quadratic term, 4r squared, appears on both sides of the equation. They completely cancel each other out, instantly turning a scary problem into a basic linear equation. Dividing by 196, we arrive at our final answer. The exact radius r equals 10. Thank you for watching. Please subscribe to Math with Tan for more visual mathematics.